Alright, number 1 of your review says define the following and give an example of each. So the first definition is a rational number, which is all positive and negative whole numbers, fractions, and decimals. Alright, some examples could be 1/2, -4 and 2/10, +6, -5 and 5/10. Those are all examples of rational numbers. Alright, the next definition is an integer. Integers are a whole number and its opposite. So that could be -5, +5, +1, -1, or +3, -3. And the last definition is a whole number, which is any positive number that is not a decimal or fraction. So I could just list 1, 2, 3, 4, and we could just keep going and going and going. Those are all of our whole numbers. Alright, number 2 says label each number with rational, integer, or whole number. So remember when we're labeling these and giving them names, we want to give them the most elite, specific name that we could possibly give them. Okay, so the first one is 75 hundredths, so that would be rational because it is a decimal. 55 would be a whole number. Remember, we push it all the way into the middle of our circle. If it's a whole number, it's also an integer and it's also rational. -213 would be an integer. It is also a rational number. 0 is a whole number. We can push it all the way into our circle. It's also an integer and it's also rational. And the last one is -35 hundredths. That would be a rational number because it is a decimal. Alright, number 3 says Jill went to visit her friend Anna on Friday night. Anna is a professional diver and was sharing some of her successes and goals with Jill. On her last dive, Anna said she saw a shark -38 and 9/10 from sea level. Is her statement true or false, and why? So this statement would be false, and the reason that it's false is because she says that she saw the shark -38 and 9/10 from sea level. So she's talking about distance, and remember, distance can never be negative. So our answer is false because distance can never be negative. Alright, number 4 says write an addition and subtraction equation for each. So remember when we're drawing our number line models for addition and subtraction, they always start from 0 on the number line. So our first integer in our equation will always be wherever we go from 0. So if we look at this first number line here, it's going from 0 to +2. So my first number or integer in my equation would be +2. Alright, let's write our addition problem first. So I have +2, I moved to the right. Then I kept moving to the right, so we need to count how many we moved to the right. Let's see, 1, 2, 3, 4, and 5. So we moved 5, and then wherever we land is our answer. So 2 + 5 = 7 would be our addition problem. Alright, let's write our subtraction problem now. So remember, our first integer is just 2. Subtraction means to do the opposite. So the first one we always model, so that would be moving to the right, 2. But remember that the second one means to do the opposite. So if we moved 5 units to the right, we need to do the opposite of going to the right, which would be going to the left. So we would go to the left -5. So remember, if we wanted to label it, normally going -5 would be moving to the left, but because it's a subtraction problem, we move to the right, and then we landed on +7. Alright, with the second one, we start with 0. Our first integer goes to -2. So let's write our addition problem first. We have -2, and then we keep going to the left. So that means when we move to the left, we're going to the negative. So let's see how many we move to the left. 1, 2, and 3. So -2 plus -3 equals -5. Right, let's write our subtraction problem. Remember, the first integer is always where we moved from 0, so it's still -2. Except this time we're going to have a subtraction problem. We want to do the opposite. So if you notice, we went to the left 3. So the opposite of going to the left 3 would be going to the right 3, which would be +3. So -2 take away +3 would equal -5. Alright, remember we did the opposite. First we moved to the left 2, and then we're doing the opposite of going to the right, which is +3. We're doing the opposite, so we're going to move to the left more, and then we land on -5. Alright, number 5 says write the equation represented below, and then explain how you know if it's addition or subtraction. So when we see these integer models, first we want to look to see if anything is being taken away. And so if you look at this one here, nothing's being taken away, so I know it's got to be addition. Alright, so first we want to start with our first group, which is +3. Remember, we're not taking anything away, so it's addition. And we're adding -4. So our second group was -4. Right, and then whenever we cancel out our 0 pairs, we're left with -1. Right, and we know it's addition again because nothing is being taken away. Number 6 says write the equation represented below. Explain how you know if it's addition or subtraction. So with this model, we see that something is being grabbed and taken away. So we know that automatically this is a subtraction problem. So remember, whenever we have subtraction models, we have to add 0 pairs until we have what we need to take away. So the first thing we need to look at is the first group. We're not going to look at the 0 pairs because those are what were added in. So our first group was -3. I know that it's a takeaway problem, so it's going to be subtraction. And then now I need to see what's being taken away. So if you see here, they circled +4, and they took them away. So -3 take away +4, and then whatever we're left with would be what it equals. So we have -7. And the reason that we know it's a subtraction problem is because we see something being grabbed and taken away. Number 7 says write the equation represented below. So we have a number line here, and remember, every time we see those jumps on the number line, that means multiplication. And when we have multiplication problems, when we read them, that means blank groups of blank. So first, we need to see how many groups we have. So here's one group, and then here would be 2 groups. So I have 2 groups of something. I need to see how many groups, or how many are in each group. So I can count 1, 2, 3, and 4. So we're moving to the left, so it's -4. So 2 groups of -4, so we would write that as 2 times -4 equals -8. Number 8 says write the equation represented below. So again, we know that this is multiplication because we have our little multiplication symbol up here. So So we need to see how many groups of something that we have. So on this side, we have positive 3. So we have positive 3 groups of negative 3. So 3 groups of negative 3. And then our answer is negative 9. So 3 times negative 3 equals negative 9. All right, number 9 says Karen deposited $25 in the bank on Monday, $50 on Wednesday, and $15 on Friday. On Saturday, she took out $40. Karen's original balance was $100. What is her balance now? So, remember, anytime we have word problems, the first thing we should do is underline any keywords that we see. So first, I see deposited $25. So I'm going to underline deposited, and then I'm going to circle the amounts that I know she deposited in her account. So $25, $50, and $15. Then it says she took out $40, and then her original balance was $100. Okay, so first I need to remind myself that depositing money means to add it to our bank account. So I want to first find how much she added to her bank account. So I need to add 25 plus 50 plus 15. So when I add those together, I get $90. So she added $90 to her bank account. She deposited that money. So if her original balance is $100, I want to add what she deposited into that account. So I'm going to add $90. So now she has $190. But then it says that she took out $40. So I need to subtract that amount from her total balance. So I'm going to subtract 40 now. So now her remaining balance is $150. Alright, number 10 says a scuba diver is 55 feet below sea level. He ascends to 3 feet below sea level. What is his change in depth? So I want to know how many feet he ascended from negative 55 feet below sea level to negative 3 feet below sea level. I want to know how much changed between negative 55 and negative 3. So, I could do negative 55, take away negative 3. So if we do the boxing method, we have negative 55. Then I have a negative 3. So I'm going to change that negative to a positive. Same signs add, different signs subtract. So I have negative 55, positive 3, so I'm going to subtract because they're different signs. 55 minus 3 is 52. Now, if we were solving this using the boxing method, our answer would be negative because the negative army wins over the positive army. However, it's just asking us for the change in depth. Okay, so we just want to know how many feet, the distance between negative 55 and negative 3. So our answer would be positive 52 feet because we're just looking for the distance between negative 55 and negative 3. Alright, number 11 says the Gazelle football team made 5 plays in a row where they gained 3 yards on each play. Then they had 2 plays in a row where they lost 12 yards on each play. What integer represents the overall gain or loss of yards? Alright, so first I'm going to underline just some key words that I see throughout the word problem. So I see 5 plays in a row, each where they gained 3 yards on each play. Then they had 2 plays in a row where they lost. So here they gained, and here they lost 12 yards on each play. Alright, so I could draw a picture just to kind of help myself with this problem. So let's say here's my football field. I don't really know where they're at on the football field, so I'm just going to say here. They're right here. Alright, so they gained 3 yards for 5 plays in a row. So here's 1 play, 2 plays, 3, 4, and 5. So this is where they gained yards. So each time they gained 3 yards. So we could do repeated addition, do 3 plus 3 plus 3 plus 3 plus 3, or we could just multiply 5 times 3 and we get 15 yards. So they gained 15 yards. Alright, then it says 2 plays in a row, they lost yards. So they're going to go back this way for 2 plays. And each time they go back, they're losing 12 yards. So now I want to find how many yards they lost. So I could do 12 plus 12, or I could just do 12 times 2. And I get 24 yards. Alright, so they gained 15 yards, but then they lost, so I'm going to take away now 24 yards. And now we can just use the boxing method to solve. So we have 15 yards, we have negative 24 yards, same signs add, different signs subtract. One number is positive and one's negative, so I'm going to subtract. 24 minus 15 is 9 yards. Then I'm going to ask myself, which army is going to win, the negative or the positive. The negative army wins, so they lost 9 yards. So negative 9 yards would be our answer. Number 12 says, which pair of coordinates does not lie on the line shown on the graph? So if you look at all your answer choices, they're all improper fractions. And I don't see any improper fractions on my grid, so that means I need to change them. So I have to ask myself, what is 8 divided by 2? And I know that's 4, so I'm going to go ahead and change all my answer choices. So this ordered pair would be 4, comma. Then I have negative 16 divided by 2, which would be negative 8. B says negative 6 over 2, or negative 6 halves. So negative 6 divided by 2 gives me negative 3. And then negative 16 over 2 we said was negative 8. C is 16 halves, or 16 divided by 2, which is positive 8. And then I have negative 16 halves, which is negative 8. Then D says negative 4 halves, which is negative 2. And then negative 4 halves again, which is negative 2. So now I need to go through and I need to check to see if these coordinates are on the line shown on my graph. So remember, we start at the origin. We're going to move to 4. Also notice that our increments, or the intervals, are going up by 2. So I need to go to positive 4 on my x-axis and then down to negative 8. So here would be my point. I'm sorry. Let's see. Positive 4 and negative 8 would be right about here. Then I have negative 3, negative 8. So negative 3 would be in between negative 2 and negative 4. And then I would go down negative 8. So it would be about here. It's not letting me draw a point. There we go. And then C is 8, comma negative 8. So I'm going to go to positive 8 on the x-axis and then down to negative 8 on the y. It's not wanting to let me draw on the graph. So it's about here. So those 3, they are on the line shown on my graph. So now let's check negative 2, negative 2. So I'm going to go to negative 2 on my x-axis. Then I'm going to go down to negative 2 on the y, and my point is right here. And that is not on my line, so D would be our answer. It was looking for a coordinate that is not on the line shown. Alright, number 13 says, what is the missing coordinate of Joe's trapezoid? And it gives you a picture of a trapezoid so you know what it's supposed to look like. So first I kind of want to see, I want to make sure that it's even. So I'm going to start with point B here. And I want to see how far point C is on the x-axis. So I'm going to count 1, 2, and 3. So I know that my new point needs to be 3 to the left of A. So I know that it's going to be at -3 on the x-axis. Now I need to figure out what my y-coordinate is going to be. So I want to make sure that it is at the same distance from where we were on the x-axis. So I'm going to count 3 up from where we're at -3 on the x. And I land right here. Alright, so if you look at that coordinate, the x is -3, the y, if you look, you have to make sure that you check the intervals. It's going up by halves. It's not going up by 1 each time, it's going up by a half. So our coordinate would be -3, comma, +1/2. And you could have also written that as a decimal. Alright, so we can just finish out our trapezoid. And it looks just like our picture. Alright, and the last question says list all the ways you can study for Unit 1 test. So, of course, you can use your test review to study. And also, one of the other best resources you could use is your math composition book with all your notes. And you can also flip through your binder, look at any practice assignments that you have that have been given back to you.